In this video, or this page, we'll be talking about two-way tables. It sounds like something complicated, but it's not really that complicated. That's a lot of things in statistics. I feel like they make a name for something you already know about, and it sounds scary, but it's not really. But we'll analyze the distribution of a single categorical variable today. Then we'll focus on analyzing the association between the two categorical variables. I'm having a hard time today. In this example, we'll talks about body image. So it asks, what's your perception of your own body? Do you feel that you were overweight, underweight, or about right? A random sample of 1,200 U.S. college students answered this question as part of a larger survey. The following table shows part of the responses. So 1,200 people, that's a lot. They're just focusing on these five, it looks like, 5 people in this table here. The left-hand column talks about the student. They're just numbering them. They're not giving names. Student 25, student 26, student 27, etc., etc. And then just the right-hand column says which of those 3 categories does the student feel like they fall under. So overweight for the first student, about right for the second, underweight, and so on. Let's see. So here are the questions we investigate. First, what percentage of students in this sample fall into each category? How are students divided across the 3 body image categories? Is there a pattern in these responses? Which response is the most common? It's difficult to answer these questions by looking at the raw data because the raw data is a long list of 1,200 responses. We can't see patterns easily by looking at a list, so we summarize the distribution in a table. Recall from summarizing data graphically and numerically that we've previously gone over that in a graph that summarizes the distribution of quantitative variables, so remember quantitative variables, that's a variable that's represented by a number, or numerical, I guess. Numerical. So qualitative is non-numerical, but quantitative, just think about the root name there is quantity. Quantity is like the number. So a quantitative variable, we can see the possible values of the variable, the numerical values. And the other thing we can see is the number of individuals with each variable value or interval of values. Here we use a table instead of a graph to summarize the distribution of the categorical variable. Because here, it's not like people gave a number response, they gave a categorical response. Were you in the underweight category, overweight category, or just right category? Those are not quantitative because they're not numbers. We create a table so that we can see first the different values or categories in the variable that the variable takes on, and then 2, how many times each value occurs, the count, and more important, how often each value occurs, by converting the counts to proportions. So here's a table for our example. Here we are. It looks like the very first row, the topmost row, talks about those who categorize themselves as underweight. 110 people of the 1,200 categorize themselves as underweight, which represents 9.2% of the population. And they showed the proportion here is 110 out of 1,200. If you divide those 110 divided by 1,200, you get 0.092, but of course that's in decimal form, so we had to move the decimal over twice to the right to get the actual percentage of 9.2%. And then the second row talks about those who categorize themselves as overweight. There were 235 people in that category. 235 out of 1,200 represents 0.196 of the population, which if you move the decimal over, you get 19.6%. The last row talks about those that categorize themselves as about right. 855 students categorize themselves as about right, not underweight, not overweight. 855 out of 1,200 is 71.3%. So obviously the majority of people, the vast majority of people, consider themselves about right. We can use a stacked bar chart to display the distribution of the body image variable. Note that this distribution is completely described by the 3 percentages, 9.2, 19.6, and 71.3, because they add up to 100%. Those 3 percentages. It corresponds to the 3 categories of the body image variable: underweight, overweight, and about right. The percentages add to 100 because all 1,200 individual responses fall into one of these 3 categories. Not that the percentages actually add up to 99.9 because we rounded percentages. So that's true. If you're ever add percentages and you don't get 100, as long as it's close, then you know it's probably right, because yeah, when they did this calculation here, for example, the actual 235 divided by 1200, if you try it, it's probably not exactly 0.196. It's probably 0.196 something something something, more digits, and same thing here. So because we rounded, it might not quite be 100, but as long as it's close to 100, then you probably have the right numbers there. We can use a stacked bar chart to display. I already said that. The percentages actually add up to 99%. Okay, so you can see it's kind of nice to have the stacked bar chart, like they said, because it shows kind of the proportions. So of course 71.3% of the students said about right, and it kind of shows what proportion of the overall. This that we've marked off here, this about right category, represents 71.3% of the total. So it's kind of a nice visual way to show the proportions.